Okay, in this video we are going to continue with an example of factoring. And this particular example is going to be a special technique that's called factoring by grouping. Here's an example where we could use factoring by grouping. We'll have 2k cubed plus 3k squared minus 18k minus 27. This example does look different than other examples we've looked at. First of all, notice that it does have a k cubed in it. It also has 4 different terms. When you see a pattern like this, you might think about trying to factor by grouping. To factor by grouping, we're just going to factor out from these two sides of the expression. What could we pull out of a 2k cubed and also out of a 3k squared? Well, the greatest common factor of just these two terms is a k squared. So I'm going to pull out a k squared. What's on the inside? K squared times what gives me 2k cubed? That would be a 2k, because k squared times 2k is 2k cubed. Plus, k squared times what will give me 3k squared? Well, that would be a 3, because k squared times 3 is 2k squared. Now we look at these two terms. Is there anything that we could factor out of an 18k and also out of a 27? Well, I guess I can pull a 9 out of there. These are negative 18k and a negative 27, so I'm actually going to pull out a negative 9. What's on the inside? Well, negative 9 times 2k gives me negative 18k, and negative 9 times positive 3 gives me a negative 27. What we have here is very good. This is showing us that we have, in this term, we have a factor of a 2k plus 3, and also in this term we have a factor of a 2k plus 3. That's what you want to see if factoring by grouping is going to work. Since this term shows up in both, this factor shows up in both terms, we can factor it out also. So we're pulling out a 2k plus 3, and what has to be on the inside? Well, 2k plus 3 times k squared is how I'm going to end up with this one. So we put down the k squared, and 2k plus 3 times negative 9 is how we end up with this term. You can check for yourself to see that if we multiply out what we have here, we are going to end up with what we had originally. But we're not done yet. We can continue factoring because this is a difference of perfect squares. So I'm going to bring down the 2k plus 3 and factor this difference of perfect squares into a k plus 3 and a k minus 3, like this. You can check your answer by multiplying together these two factors, getting a result. In fact, multiplying all of that times k minus 3, you should end up with what we had in the beginning. Here is the final factored result.